So using the if you solve the introductory case, which is the spam detecting system, then we can see. I think we already see this table. And if you calculate the probability, when the response is 20 or 21, the probability will goes up. But actually, what was the p? B is this one, right? It's about this times 100 is about 10%, right? In terms, not in the probability, but in terms of the odd, actually this is about 10% increase, right? Yeah, exactly this is about the 11, but roughly this is a 10%. And then hyperlink also has a probability change, this 0.5 and minus 0.014 is from here, right? And using this one, you can estimate how much the odd will change, but not in probability. Now we will talk about the accuracy rate. So instead of R square, we need something more, right? There's no universal goodness of fit measure. Binary case. Binary case is really hard. Residual analysis is meaningless here. Yeah, we can do it, but it doesn't tell you anything, right? So how can we use how good my model is? Previously we use R when we compare the two different number of predictor. We will use adjusted R, but here we cannot do that. So we will actually make a prediction. So actually the logistic regression will give you the probability, not the exactly 0 or 1. But using the probability, we will make up the actual prediction, not only probability. We can predict this will be 1 or this will be 0. So you can create a certain criteria. If the probability is greater than 0.5, yeah, I will predict this case is a 1. If probability is less than 0.5, I will predict it as a 0. And then we can calculate the accuracy rate. It's a number of correct prediction divided by total number of observation. So it's like a total number of prediction. So even though it's an observation, you can make a prediction, total number of prediction, and total number of correct prediction. Then you can calculate the accuracy rate. The accuracy rate is pretty good, but accuracy rate itself has a problem. So we can predict our cases and then make a prediction using okay, probability is less than 0.5, so I will predict it 0. This is greater than 0.5, so I will predict it 1, and so on. So out of 500 sample record, and then binary prediction match the spam value in the 394 and 397 record. So you can calculate the probability, I mean the accuracy rate here, the 394 out of 500. Here 397 out of 500. You can calculate the rate, and then the accuracy rate will be, this one will be 78.8, right? This is a 79.4% accurate. Logistic regression is better, slightly better. And how can we find out the calculate the accuracy rate? Is creating the linear model and then general linear model with family binomial, and then you can predict with a linear model. You can just using predict model, and then you can find out, and you can predict using the logistic regression model, and then you have to type in, otherwise it will not be a prediction. And then you turn into the P, which is the probability, into the Y prediction. So if else is if this condition is true, this is condition. So if else function is similar to the if function in Excel. Condition, and if when the condition is true, this is the value when condition is false. So if it's greater than 0.5, we will make it 1, and if it's false, which means it's less than 0.5, we will predict 0. And then compare how many is spam. This is the real number, actual. This is our prediction. If actual and the predictions are the same, and then we will get 1. So this is just a conditional statement, so the outcome will be 1 or 0. If it's true, we will have a 1. If it's not true, we will get 0. So whenever we have something like this, if you state just A equals, the greater smaller than B, then if this is true, you will get output 1. If it's not true, you will get output 0. And then if you calculate the just mean, you are calculating how many 1 and how many 0, so you just add up to all of them, right? 1, sometimes it's the true, which is matched up. You got wrong prediction, and then right prediction, right? Right prediction, wrong prediction, and so on. So if you just add up, actually the number, because what you have is the total summation is actually the total number of matchup, so correct prediction, right? And then mean means you divide by the total number. So actually this is the total number of prediction, and then the numerator will be the correct prediction. So this will be the accuracy rate. And then why I multiply the 100 is to make it percentage. Okay, so this is the just I will bring the spam data here, and then I will do the linear regression model, and then from here we calculated the mean, right? So okay, this is the graph you can find, and also we can find all the estimation here using linear regression, right? And then how I draw the graph is using prediction here, right? Sequence is like this. Sequence is 5 to 50 by 5. So this sequence will give you the bunch of numbers is from 5, 10, 15 up to 50. This is what it means. It's a starting 5 and to the 50, but what will be the step size will be the 5. Then you will have this one. This is the number of recipient will be the sequence number, but however number of hyper and the number of character will be just calculating the mean. And then you will make a prediction here. Again, this is the vector because it contains the 10 numbers, but here this is just the mean, one number. and this is one number, and then you can make a prediction with a linear model and with a logistic model. Again, since I want to see the probability, you have to write down the type is a response, and then you just plot two of these things, and then I will not go over the detail because you don't have to make it nice. You can always Google, and you can easily find out what is the option, so you can see how it will work. Accuracy rate is the we do this way. So if I run, and you can find out the accuracy rate here simply.